This is the P4 paper from January 2023. This is question number 1, which, as we can see, is a partial fractions question for part A, and then it's going to be binomial expansion for part B. Let's jump straight in and do part A. So part A says that we've got fx is equal to this fraction, 5x plus 10 all divided by 1 minus x, 2 plus 3x, and we want to express that in partial fraction form. So it's a straightforward partial fraction. It's just a over 1 minus x, and it's b over 2 plus 3x. So looking at this right-hand side, I want to change that into one fraction. That times that times that, and the bottom two times together. Absolutely straightforward for you, I would hope. So we're going to get a 2 plus 3x plus b 1 minus x all divided by 1 minus x 2 plus 3x. Well, that's the same as the left-hand side. Let's just use the magic of the iPad to say that's just the same as the left-hand side there. And what we're now able to do is to just equate the top lines then. Equating the numerator. Just get into a nice rhythm when you're doing these questions, right? They're the same sort of idea each time. So that means I'm going to get 5x plus 10 is equal to a lots of 2 plus 3x plus b lots of 1 minus x. And here I want to get rid of the a and get rid of the b. So if I set x equals 1 first of all, then that part there will be 0, which means that the third term will be 0, so the term with b will be 0. So if x is equal to 1, I'm going to get 5 plus 10 on the left-hand side here. 15 is equal to a lots of 2 plus 3, and as I say, this term here is going to be 0 there. That's 5a equals 15, right, so a is equal to 3. I also want to get rid of the other term, so just quickly, hopefully this is no problem to you at all, but if 2 plus 3x equals 0, 3x equals minus 2, x equals minus 2/3, so that's what I'm going to set as my next value for x, so that I get rid of the a term this time. When I'm doing that, I don't need to particularly have all that written down, so let's just get rid of that bit there. If x is equal to minus 2/3, then putting that in, I'm going to get minus 10 over 3 plus 10 is equal to, well, I don't need to worry about this bit too much, that's 0. And then plus b times 1 minus 2/3, that's 1 plus 2/3, that's 5/3, so 5/3 b. But I'm sure you don't have any problem in doing this simple algebra stuff here. We get that if you go through that, b will work out to be equal to 4. And so the partial fraction part of it then is that 5x plus 10 all divided by 1 minus x 2 plus 3x can now be written as 3 over 1 minus x and 4 over 2 plus 3x. Okay, so that's part A done. Now part B, finding ascending powers of x up to and including term in x squared. So we've got to do the binomial expansion up to x squared and give each coefficient as a simplified fraction. Okay, so just show all you're working out for this as we're going through B. We've got, this is my new function. And if I'm going to do binomial expansion on that, this is 3 lots of 1 minus x to the minus 1 plus 4 lots of 2 plus 3x to the minus 1. So when we're doing this, I'm going to need to expand that using the binomial expansion. And before I can expand that one, I need to put it in the form 1 plus nx. But we'll do all that separately. We'll do this down here. Now let's just take our time to do it. So I'm going to do the first bit. 3 lots of 1 minus x to the minus 1. I'll just remind us that we're going to be using the fact that 1 plus x to the n is equal to 1 plus, and it's nx, it's n minus 1 x squared over 2 factorial plus, and it keeps on following that pattern, but obviously we only need up to x squared anywhere when we're going through and doing this. Do you know what? I'm actually going to leave that as part of my answer. You don't necessarily have to have that bit in, but I know I'm going to be using it a couple of times here. So to actually now say, so this is going to be, don't forget the 3, just be really careful not to make any silly mistakes here. So the 3's still in there. 1 plus nx will be 1 plus, n is minus 1, and x in this case is minus x. It's the thing that you're adding on to the 1 here. Plus n minus 1, so minus 1 minus 2 minus x all squared over 2 factorial. The only way you get good at doing these is by doing lots and lots of practice. This bit here should have caused you no issues whatsoever. Once we've got the accuracy of that bit, then just tidying that all up, that's going to be 3 lots of, in this case relatively straightforward, 1 plus x, the 2 and the 2 factorial, those two can cancel with that one there. So we get 1 plus x squared plus dot, 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 dot. Okay, so that's the 3 one. We also had the one that's got a 4 in, and that's 4 lots of 2 plus 3x to the minus 1. So we've just got to be careful here then that this is 4 lots of, here when we're looking at 2 plus 3x to the minus 1, we can't do that. We need 1 plus. So what I've got to do is divide everything in the bracket by 2. Well, you can't just divide everything in the brackets by 2. You've got to take 2 out. We're not taking 2 out. We're taking 2 to the minus 1 out. If that's causing you a problem, you've not worked hard enough, because that's a very, very standard thing to do. So just tidying that up then. 2 to the minus 1 is a half. It's 1 over 2. So 4 times that is going to give me 2 here. And now I can worry about actually doing 1 plus 3x over 2 all to the power of minus 1. Going to be using the same formula up there. So it's 1 plus nx, n will be minus 1, x will be 3x over 2 here. Sorry, that handwriting. Plus n minus 1, so minus 1, minus 2, 3x over 2 all squared, all over 2 factorial. I'm going to put that all over 2 factorial just there. Plus, and again, we don't need to go any further than that. So if we're tidying that up, that's going to be 2 lots of 1 minus 3x over 2 plus 9x squared over 4. Just take your time with all of the bits when we're doing the binomial. So my actual fx here works out to be, you could have multiplied these out already, but I just want to keep it all together and then do it all in one go in a minute. So it's 3 lots of that. It's 2 lots of 1 minus 3x over 2, 9x squared over 4. And then you've just got to multiply that all out and take it. So 3 times 1 is 3, 2 times 1 is 2, so that's 5 there. We get 3x. Now the 3x and the minus 3x will actually cancel each other out there. So we're actually going to get 5, and we're going to get 15 over 2 x squared there. So fx works out to be equal to that, and that is part B. Done. Give each coefficient as a simplified fraction. Yeah, I've done that. No other issues. And then part 2, that's B part 1. B part 2, always relatively straightforward when we do this. There's a lovely extra mark to just get here. Let's call this is part 1. So B part 2 here is that what we want is from this part here, we're going to say modulus x would be less than 1. And from this part, or rather not that part there, from from that part in here, we're going to say modulus of x has, well, let's just do it slowly, sorry. Let's do modulus 3x over 2 has to be less than 1. So if we get that, sorting out the right-hand side here, if 3x over 2 is less than 1, then 3x is less than 2, x is less than 2/3. So we've still got modulus x less than 1, modulus x less than 1. Tidy up my presentation of that. And then given those two parts, for the whole expansion to be valid, it's got to be the smallest possible of the ranges. So make that very, very clear at the end. Modulus x less than 2/3 is what fits in for all of it. I've taken quite a long time to do that one mark, but that's just to go through a little bit slowly as we're doing that one. Okay, so that's question number 1, all completed. Hopefully that all makes sense.